An official welcome, everybody, to today's webinar. We are really stoked to talk about a very interesting topic today, also very much edge of technology topic. It's all about having multi-agent systems, handling complex engineering tasks. We've brought lots of very interesting insights, challenges, and our views in here. And yes, the recording will be recorded, so there will be also like follow-up questions and lots of things happening today. But before, I would like to introduce us two so that you know whom you're talking to. So Ram, do you want to introduce yourself?
Yeah, thanks, Moritz. First of all, hi, everyone who joined our webinar today. Super nice to virtually connect with you. I'm Ram. I lead our AI activities and also the product at the moment. I talk to our customers every day, see some of their problems with automation, with repetitive tasks, and try to bring them into our product as solutions. And happy to do this webinar again with you, Moritz, and answer some of the interesting questions that you always pose.
Amazing. Really glad to have you here with us, Ram, today. I'm a CEO and a founder of Synera. I had the honor to actually work on the AI topic within the last couple of months and even years now. So I'm really stoked to also see this like kicking in to boost efficiency at our customers. And yeah, we prepared lots of interesting things today. We would like to guide you through. And before we get started, actually, just to give you like an idea about what we're talking about today, we'll start with a little introduction into the challenges that we are facing, especially then asking the questions where also multi-agent systems especially make sense, because you should only use these complex technologies if it really is needed. So we will dive a little bit into the theory around it. And then we will like to highlight one specific process, which we kind of like found out during lots of discussions with you guys, that is so complex that it actually needs multi-agent system to be automated. It's all about RFQ processes or request for quotes processes. Then we kind of like use this example workflow or this process in order to kind of like differentiate between single agent versus multi-agents. So we've gathered some of the latest research out there to guide you a little bit, to give you insights of how to distinguish between these two different approaches. And then I guess the most interesting part in section number 4 will be live demos. So we will present multi-agent systems, how they access, especially like complex tasks like RFQ processes. Then we will wrap it up. And of course, also at the end of the webinar, we'll have a Q&A session. But even if you also want to jump in between, you can just use the chat or the Q&A button here in Zoom and just ask your questions, and then we will try to also answer them on the way if it makes sense from the context. Otherwise, we will just postpone it until the last Q&A session. So yeah, we have roughly 45 minutes, maybe 1 hour. So it's up also to you how many questions you will ask in the beginning, and really stoked to really get started. And I would say, yeah, let's just really dive right in with an initial question that we have for you guys. So the question would be actually how many experts we have in the room here when it comes to multi-agent systems also, or agentic AI, versus if you think this is really useful, because usually there's lots of expectations out there. So multi-agent systems might solve everything. That's more on the, I think it's useful axis, versus I'm a real expert. I already have tried them out, maybe with some minor things, and you really know how complicated they are to build. And for starting, yeah, just scan this QR code with a mobile phone, or Ram also posted the link to the Mentimeter here, and try to answer those 2 questions so that we can kind of like get an example on where we are actually sitting here with the audience today. So it's definitely a trend that we have, at least most of the audience haven't built multi-agent systems so far, which is kind of like expected because it's a very new technology, obviously, especially in engineering. And the usefulness or value kind of is spread across the horizontal bar. Ram, what do you think?
Yeah, I think, like you mentioned, building agents is a high barrier for now, and we will see later how this can be a low barrier thing in Synera, but also pretty interesting how different the perceptions are. I think it's all happening with the AI. Everybody's talking about AI, so there are different mixed perceptions for sure.
Amazing. So yeah, thanks for this initial insights. We're definitely on the bottom right corner, which I guess is the perfect setup to get started and really to educate a little bit, and also to give you examples how they could be built, and also what they can't and what they can do. So yeah, thanks for this. Thanks for the presentation. And let's directly jump in with the very first question about asking why actually engineering challenges are so complicated and how these engineering systems might actually help us here to support it. And I'm not sure if you have like looked into the news lately about the messages that pop up, like really like the main challenges we are facing as hardware developers, as engineers today, is the shortage of talent. I've like come over this topic basically in all of my customer talks. The older generations transitions towards the retirements. We have problems bringing in the new talents which actually know how to do things. We have huge productivity pressure, do less with more, do more with less, the other way around. It would be nice to do this. And expertise is definitely a bottleneck. And one of the main actually news that I just read here was, for example, from the Volkswagen group. Actually, they need to be there at China speed. That's their vision 2023 mobility. So there's real pressure on the table. And the question is actually, where do we see these kind of, let's say, high-level challenges really in engineering everyday works? So we've tried to break this down into some kind of like challenges. And there's a nice study actually from Siemens and also from Bouchers, 2 years old, 2.5 years old. And they asked basically small to medium-sized companies, but also large companies like the bigger enterprises, where do you really see the most time losses in your R&D departments? And if you look into these graphics here, it's pretty clear that basically half of the inefficiencies really come from the meetings, like people sitting together, aligning, talking, bringing everybody on the same page. Then obviously interruptions, nobody likes this. Like you're working on a detailed task, then your manager comes in with some coconuts and asking you to do other things. So that's also cool. Also repetitive tasks is a thing. Like all of these like documentation and stuff like this, it's going to be annoying. And there's also inefficiency in collaboration. So this could be either like alignment between different departments, different tools, and all about like working together on one project. And I guess one of the things which we have been really experiencing in the past, which is pretty much capable of being automizable by agents, by single agents, is definitely the interruptions and the repetitive tasks. I mean, even if you only do rule-based automations like script writing, this is something where agents can help or rule-based can help. And we've already showed this in the last webinar. We will also present a QR code later. So if you want to watch the single agent capabilities, I guess this is the thing where they really come in handy. And they can really come up with these, let's say, intermediate steps in here. But the real question is, what about the more complex tasks? So collaboration, like really human-to-human interaction, bringing everybody on the same page when there is like multiple streams in the process, or a highly complex process with lots of different meetings and stuff like that. That's something where really, single agents or even like these automations have a hard time until now. And this is something where we definitely see those guys being able to add some value. And to give you a little bit more a clear picture what we mean when we talk about more like a complex process, it's typically, if you imagine a project going along, maybe with 3 or 4 stakeholders or departments, and the project starts, and then you actually want to like have some input from your other departments. Maybe they are on vacation, like now in summer times. And then you have these sync points where you actually need to bring everybody on the same page. So it seems really the more people, the more departments are involved, the more tools that are involved, the harder it gets to synchronize all of these streams and really to work on the same data level and the same data quality. So these processes really are the ones that we are looking for when we're talking about multi-agent systems. And I guess everybody of us can rely to this. The bigger the projects, the harder it is to get it done in time. So the idea actually behind this is, well, what about actually agents would be supporting these streamlines? So just imagine if agentics or multi-agents working together as co-workers could interact with each other and kind of neglect all of the waiting time between the different departments, the different data sync points and stuff like this. So really having handshakes instead from human to human, more into a kind of like machine to machine interface. So this basically would mean less meetings. Maybe we cannot neglect all meetings, of course, but at least only like a quality assurance meeting at the end to kind of like discuss what the agents have come up with preliminary results. Or if, for example, two software tools like a design department and a stress department would need to work together, having two agents actually like being able to connect to those tools that these agents, that these humans usually use, and synchronizing them automatically overnight, even if the humans are on vacation, this would be definitely a game changer when it comes to efficiency. And I think this should be like the idea of today's webinar, to really see if something like this is feasible and how far we already can come today. But before we actually like directly start into also showing you an example process on this, I would like to ask you another short question, just to see where we are. If you have realized actually like a project time, typically one, maybe you select the projects you're working on at the moment or last week, and try to differentiate between actually the project duration, so how long does it take until the project is finished, versus the real engineering time that you are working productively. So we try to see if there's maybe some gap in here, like we have shown in this nice animations in here, if this resonates also with your experience of your projects that you are currently working on. And I would say this gives already kind of a clear picture that we are maybe on project durations and maybe like 50-ish% of the project time. What do you think, Ram? Is this something which resonates also with your experience?
Yeah, I think we have talked to a couple of domains and industries, and this seems to be a pattern that there is a strong correlation or a discrepancy between these two numbers. And it's quite interesting to see how it's also tending more towards or leaning more towards this upper left corner.
Agree on this. So again, thanks for your participation. It kind of resonates with the thoughts what we also had in mind. So this is the scope actually of today's webinar. Let's try to find ways to kind of like bring these engineering time basically at the same level to the project time. That would be perfect. But let's see how far we can get there with multi-agent systems. So Ram, I would like to now jump directly into a real kind of use case, the RFQ processes, which kind of like should guide us through also the live demos and so on from now on. Maybe you can give us some explanation why these processes are so interesting for multi-agent systems and what they are about.
Yeah, thanks a lot, Moritz, and thanks everyone for participating in the poll. Super insightful. We ask ourselves the question, what kind of processes are typically containing characteristics that Moritz talked about, including engineering work, including a lot of human collaboration. And both at the OEMs and supplier side, we see this request for code as a process that is like the bridge between these two worlds. And that is what we want to show today, how we could build a solution for this highly complex process using multi-agent system. Now, before we talk about jumping into agents, let's try to absorb the problem a bit. So the RFQ is a complex multi-domain process. So there is usually like a sequential process. So what happens is, as soon as a quote is received, there are some team members who are assigned. So this is usually in number what we saw between 4 to 6 engineers. They all distribute themselves the specification, and the engineers work together through meetings, through a lot of engineering tools to come up with a first concept design. And this design is then sent to a feasibility check to the manufacturability and the costing departments and so on. And then the planning happens. Okay, if we realize this design, how are we going to manufacture it? And then the quote is sent. And what we saw is, depending on the product type, this takes from days to weeks. And actually, we have heard from customer, it takes months to just do this once. And like we saw, there are different components on which this time is spread. And one of our customers said that they would like to save up to 50% with multi-agent systems. That would be the ambition. And that's where we are progressing towards. And this is because OEMs always expect faster responses. There is basically less and less time to react to these RFQs because the competition is getting higher, and this directly impacts the win rate. So now the question is, we see this problem, we see this is complex, this is multi-domains. How can we solve it with agents? Now, there are a couple of things that we can do to solve this. We could either build a single agent system, or we can build a multi-agent system, which is the highlight of today's session. And I'm also curious to see what your thoughts are, Moritz, and also audience later, how you see this. But before we jump into the technical details, let's take a step back. And for people new here, let's define what an agent is. So AI agents are based on large language model, and they are super good in two things. And that's why we see this wave of AI riding all across technology. So basically what they have is a large language model, which kind of propels this creativity and intuition. And they have an orchestration, or let's say more components added onto it, which is like memory, communication abilities, and reasoning. But what they always missed was the ability to interact to engineering tools. They can write, they can read, they can even create images, but talking to engineering tools is always a challenge to solve these kind of problems. And in Synera agents, what we allow these agents to do is to interact with engineering software like SCAD, CAE tools, even link to Excel databases, and so on. So this is what an agent is. Now the question is, why can't we build the whole thing with a single agent? Imagine one agent is like a human counterpart. Sometimes I like to ask the question myself, can one human tackle such a complex process like RFQ? And for me, the obvious answer is no. And this is also what we see with LLMs or single agents, that they have limited intelligence and model capability. When we only have one agent, they lack this focus, they lack the experience across multiple domains. Of course, they are obviously great for automating one particular scope, one particular isolation. But if there are multiple domains, like imagine CAD, imagine FEA, imagine production planning, this is too much for a single agent to handle. And there are so many tools involved in each of these steps. And that is where multi-agent systems really offer a difference. Because now what we do is, instead of one agent, we create multiple instances of a single agent. And this means we can let the agents focus on one scope, just like how it happens in these complex processes. So now there is combined intelligence. So it's not one instance of a LLM, it's basically multiple instances with multiple focus areas. And this then eventually and obviously turns out to be perfect for automating these complex tasks from multiple domains, but still keep it flexible. And of course, LLMs are very non-deterministic systems. So that is where the challenge comes. How can we make sure we are designing an engineering system and we say we have to add more agents, but how can we balance this non-determinism versus making sure the answers are correct? And that is what we want to talk about today. Now, again, there's a wealth of knowledge available in the internet for this. So I just want to recommend a couple of resources if this picks your brain. There's one from McKinsey, which is super nice on talks about different agent use cases, but also quote a really significant aspect of multi-agents. If you're like me who likes to deep dive into mathematical stuff, please feel free to also read this archive paper that really talks about how multi-agent LLMs can kind of simulate human-like behavior.
Amazing. Thanks, Ram, for this introduction. For me, always when I try to think about single versus multi-agents, I like your metaphor actually of thinking about if one engineer can do this whole job or if it actually needs a team. And I guess this kind of also resonates now when we talk about how to actually build like a multi-agent system for a real request for quote process. I mean, these processes are super complex. They are across multiple departments, across multiple stakeholders, multiple skills. So really trying to approach them with multi-agent system is the way to go from our perspective. And just like if we try to analyze also what is kind of like the goal that we want to achieve when actually like automating RFQ processes, is that we really want to have the whole steps like the processes and organigrams mapped, also have the agents built, have maybe a supervisor structure and connecting the agents. So there's lots of steps actually that we would need to do in order to build these systems. And I know, Rami, you will show this live to us in a couple of minutes, how this is been doing. And really, if we come to the goal that we kind of automate the RFQ process, this is really valuable also from a business perspective, because as you know, if you automate engineering hours, you gain engineering hours. But if you automate a process which actually has a business impact because there's a leverage behind it, like for example, RFQ processes. So if you win deals by answering faster, or if you can like be more precise in your quotation without investing too much engineering hours, that's just a game changer for the process and for your business. And that's why these systems are not only complex and solvable with agents, but also highly relevant from a business perspective. And I guess if you look into also like already some of the agents, we definitely have sales, RFQ managers, commodity analysts, all of them kind of need to work together. And if we then like try to map this process on a very high level, like say view, I would like to also use this as a guiding example now for guiding you through the demo. And we're using a very simple assembly for this demo. It's like a filtration system in here, which kind of consists of a off-the-shelf pick and click solution. So maybe you have some already pre-built parts in your PLM system. So you definitely have somebody in your team who is like the commodity analyst. This expert or the team is actually evaluating which commodities fit best to the new system. And obviously you want to connect to your PLM databases and ERP databases, like for example, NX or SAP in here. So this is the data sources where maybe your existing domain knowledge is stored. Then obviously, if you have like an assembly, you need to have expertise in how to segment it and also like to join it. So maybe you want to go in this example for injection molding and you would like to maybe like glue it or clips it. Let's talk about this later. And maybe you also have some tools like NX here, for example, as your way to solve these tasks. Also, if you want to go for RFQs, definitely is sourcing. I mean, this is something which is highly strategic. You might want to choose between single vendor strategies, in sequence sourcing, if you can have it nearshoring, offshoring, like all of these, for example, the challenges, you need to discuss them. So this is expertise and this is also strategic discussions which are needed to be involved here. And obviously, one thing is here very important, you need to calculate the costs. So an RFQ processes, this is either should costing or bottom-up calculations. So there you have your special tools, like for example, Facton in your house, and you want to connect to them because you don't want to maybe like have an LLM guessing the prices. You want to have the most accurate solution in this. So highly complex, multiple brains, multiple peoples, multiple software tools involved. So Ram, how should we ever automate this? What do you suggest?
Thanks for the great overview, Moritz. So what you presented here is more of a linear map. And what we need to do is somehow think of how to represent this in terms of personas. I think Edward asks a brilliant question also in the chat. Why should the agents have different skills? I think this is the reason. We see so many domains here. So we want to make sure all of these are covered with the right tools and not one agent covering them. For example, not 30 different tools for one agent to handle. So what we do is take this process and kind of map it onto a structure, like a team structure. So what we now do is still map those tools. So there is still one agent that will be using SAP and NX, one agent more focused on NX, one agent more focused on the costing tool. But what we now do is add a persona. Persona in the sense we add a responsibility and a clear focus for this agent so that they represent the goal to be achieved. And now when there are multiple agents, we need to make sure that ultimately there is one coordinator and one person talking to, and that's the supervisor. So this is our first step. We try to see how can we kind of take these different tasks and assign it to different agents or people. Actually, what we see is that these are actually people doing these different tasks. But now the question comes, how can we set this up? Like what happens in reality? And this agent structure is super evolving field, and we need to see what kind of architectures we need to pick. I think this comes a lot from this LLM world, but we try to make it simple now. So when we design multi-agents, usually we can put them into any structure. It can be every agent talks to everyone. There is a supervisor that leads the team. There is hierarchical, which is clusters of many agents, or there is a custom pattern where there is a super inorganized flow. Now, one trade-off is some structures are more goal-oriented than others. So if we, for example, look at a custom structure or a network, this actually means that the agents are free to talk to each other anytime they want. And what we will see happening is that the agents kind of argue like how people argue. They say, I don't accept this design, I don't accept this requirement, and so on. So what we want to make sure is that they are aligned onto one goal. And that's why we pick the supervisor architecture. And that brings us on to the kind of the highlight here. What is the supervisor? And if you have been in one of our last webinars, we just built an agent, we didn't build a supervisor. But what we want to show is why the supervisor architecture is powerful, or let's say more beneficial for cases like RFQ. Because this supervisor doesn't need any engineering software, because all it's going to do is coordinate the process flow and activate the required agent when it thinks I need this specialized person for this task. And I think this is also what we see in real RFQ processes, that there is a project manager or a team lead, and this person is kind of the one responsible to talk to the right person, get the right information, and move on. And this agent also then forms the point of contact with the human. At the end, these will be systems that other engineers use, for example, application team, sales team, or business teams. And we want to make sure that one agent is responsible. And that is the supervisor. Let's dive right into the software and see how it works. So this is Synera, and I found my supervisor node. So I put it on the canvas, and we see it has an input called LLM, and I just picked a US Claude model from AWS Bedrock that also answers Srinivas' question. So now what I need to do is basically define the responsibility for the supervisor. So what we will do is fill out the prompts. And sometimes it's actually just prompts that do the magic or do the trick. But of course, Synera in the backside, it handles a lot of stuff. But right now, what we are doing is filling out the prompts for the responsibilities, the goal, the rules and responsibilities, and also adding an overall description to the agent. So now I just input the pre-filled rules and responsibilities. And at the last stage, we also fill out the roles and description. And now what this will form is kind of an, let's say, identity that describes the job profile of the supervisor. So just a couple of clicks, we put a supervisor onto the canvas, we assigned it an LLM, and we already have our supervisor built. So that's how easy it is to build a supervisor. And now what we saw in the system is to build the agents. Now, our last webinar was exactly this. How do we build our digital engineer? And if you're interested to talk more about tools, talk more about what really happens in these agents, I would highly recommend watching the last webinar. We built an FEA agent, which was capable of doing a couple of tasks, not just one task. It was using 4 tools. And now what we will do is focus on just utilizing these pre-built agents. And that's also a benefit of Synera. So you can build an agent and reuse it across workflows. So in the previous section, we already built the supervisor. Now let's go to the next step. So now I already have below the supervisor my agents pre-built. And what we see here is a workflow connected as a tool. So I have my commodity agent, CAD agent, assembly agent, purchasing agent, and the costing agent. And I also have these roles, responsibilities, and prompts filled out. And here comes what I call the easy part, just building this multi-agent. It's a simple flow that you can define that completely lowers your barrier to building a multi-agent system. So what I'm doing now is defining these communication channel, which agents talk to whom, and what can they do together. And now I have my multi-agent set up. So we build the supervisor, we build the agents, we define the communication flows, we assign the right tools to the right agent, and we are already at a completed system. And we are just a few minutes away from actually making use of it, and that's what I will do now. So what we will do is name this system. Let's call it an RFQ multi-agent system. We also define the server. I save it, and then we publish it. And what happens is we get this kind of an interface which allows people to talk to this. So the business engineers that we talked about earlier, so they can talk here. So I have a new chat, and the supervisor says, I can help you with commodity, CAD, assembly, purchasing, so on. So let's input more of a system requirement. So I put just my system requirements. And what we will see now is that the agents start talking to each other. So we see first the commodity analysis agent calling the tool on its own based on the instruction from supervisor. It found the requirements or the answer. We see it fetch the dimensions and so on. And now it asks the supervisor, what can I do? And the supervisor says, sure, let's call the CAD agent. The CAD agent is being called now. And it also uses the CAD tool. So it doesn't hallucinate. It doesn't create something on its own, but it actually can do the engineering task. So now what we will have is all agents talking to each other. There is a lot of engineering collaboration going on between each of them. And this is a more detailed view. And we see it's already reached to the cost analysis. And what we will see is now the supervisor says, based on your RFQ, I have created these designs. What we can also do is ask the supervisor more questions. We can ask, okay, I need 2 different volumes. Can you help me generate 2 different codes? Again, the same thing happens. These agents talk to each other. They come up with a code, and they help us take decisions. And all of this basically happens at minutes. So of course, we kind of made it faster for this webinar, but all it takes is kind of 7 to 8 minutes for this whole conversation. And this first insight already helps business engineering teams to kind of have a first estimation. So that was something in action, Moritz. What do you think about it?
Wow, Ram, that was super impressive. And I have a couple of questions, especially to those building up, because it seems very easy, to be honest, just like to draw these lines and actually to define the communication channels between especially supervisor who kind of like orchestrates the whole system and then the agents. Is it really that simple?
Yeah, actually the agents, the product that we have in Synera makes building the agents easier. So all we do is prompting, connecting agents to each other. But I think one of the primary, let's say, challenges still exists is building these tools, because these tools are going to be very custom. So company A could be using a bunch of tools that is totally different from company B. So we need to define these tools that we see the expert knowledge is still needed. But once these tools are available, the agents can be set up easily, they can be connected, they can be put into consumption faster, and they can be serving tens and hundreds of engineers. So I would say the challenge boils down to tools. And of course, what we do in Synera is making this process of creating agents much easier.
That totally makes sense, yeah. So maybe let's reflect a little bit about the question of RFQ processes, because we kind of started with a very complex process. And kind of like now, also maybe from your perspective, if you have these, I guess it was like a couple of maybe 6 or 7 agents here in total that interact with each other. What are the main challenges that you experience while building up these systems? So, I mean, humans usually they also are maybe sitting in meetings and arguing. Do you see similar patterns or similar behavior of the agents when they talk to each other?
Yeah, I think that's a good question. When we first started out building this demo, we kind of let everyone talk to everyone. And sometimes it's not needed, especially that's why we started with this sequential step. All we wanted to make sure was to map it into an organigram. And of course, the creativity of the human brain pops up. So initially, I think we connected everyone to everyone. And that's when we figured out it actually doesn't add any value. Sometimes it also doesn't even add value to let 2 agents talk. That's why in the product, we can also constrain who talks to whom. And then this part of managing the tools and the complexity is what remains. So I think that was some of the experiences. The second challenge I would say is, again, in this demo, we have some representational engineering artifacts. But of course, we see how complex databases can be, how complex documents can be. So those are some of the things we are working on. But I think in general, building multi-agent systems are much, much easier and useful as of today in Synera.
Thank you very much for these insights, Ram. I guess I especially like the way how you explained it, like the different roles, you connect them, you define the communication channels, and the real I would say effort lies in the tools. So the rule-based workflows that the agents are accessing, this is where the time goes in if you build these workflows. And also then later, like for making them robust, I guess this is something, quality assurance. There's already lots of questions popping in with regard of the details. I would like to postpone most of them for the Q&A session later, because I have like one kind of like really maybe to again like draw the bigger picture. Where does this lead us towards if we really have the capabilities to automate complex tasks like RFQs with multi-agent systems, where we actually digitalize the workflows or the tasks of the people and then just like adding them to agents. And it seems to be, at least, of course, like in the early days, high expectations, right? But also, I know bringing this to production is not easy. So there's definitely some expectations here to be managed properly, because otherwise, yeah, demos usually look great. But there is obviously a really interesting business impact if you like go into the world. And that's what I just also would like to emphasize here a little bit, because we've been talking to lots of also upper management in the latest weeks. And there's one of the, I guess, first CEOs at the moment who really like went out to the public. It was the CEO of Ford. I'm not sure if you have followed this. It was in the Wall Street Journal also like, I guess last week, 2nd of July, written. And he actually stated out that AI, especially those agents, really will wipe out white-collar jobs. So this is something which definitely might be possible, and there's some thoughts around this, how this could look like in the future. And I try to kind of for example, come up with an example how an organization, like an engineering organization at the moment looks like. And what we typically see is this kind of triangle shapes. So you have the upper management, then you have like the heads of engineering, the team leads, like also as we have seen it now in the RFQ processes. And then there is actually the engineers, the service providers who are actually doing the operational stuff, like get the projects done and really work on this area. And it seems to be that there's some transition now going on in the industry, and we might end up with some kind of like a diamond shape of actually R&D organizations in the future, where lots of the low-level tasks, like the repetitive tasks and processes like, for example, RFQ processes, might be supported by AI agents, and they will kind of like back up the engineering organization, which is an amazing thing, because actually us engineers can upskill ourselves to then build agents or quality assess agents, and we will kind of be able to tackle these huge challenges with talent shortage or doing more with less budget, for example. So it's really something where we see the industry reacting. So it's not only the AI companies telling this anymore, it's really the companies who are like feeling this, and we see the early signals that this is going towards a major shift in R&D organizations. And I guess with a solution like Synera, there's definitely some potential here to guide this transformation here along the way. To sum it up, for also the business impact is what we kind of like would like to also emphasize today is that you definitely need to identify the real process when it comes to the multi-agent system. Not every process is suited to multi-agent system. You should look out, for example, for RFQ processes, which are kind of like multi-department, complex use cases, lots of alignment, where actually multi-agent system like shine. Definitely, you need to design a suitable system. I guess, like you also explained it, Ram, you should not try to have this kind of linear process. You try to think about maybe in organizations, so how is teams structured, how actually like are people working together, and try to mimic this in the first place with the multi-agents. But also what we've learned so far, it's not always good to just copy the organigram and the processes, because us humans tend to be not that efficient. Like you could maybe model a agentic system which can work in parallel or do things overnight asynchronously. So there's advantages in process optimization as well if it comes to this agent system. And I guess the last point of today is definitely you need to balance your effort. Yeah, then creating the workflows. I guess it's something which comes down to complexity, connecting all of the engineering tools, and really make it digestible for a large language model, like, for example, OpenAI models or Claude models or Gemini models. So this is really something which we see mandatory to do. but there's lots of learnings out there. And yeah, especially if you are interested a little bit more to deep dive, I would like to highlight 2 webinars. There's also recordings out there. The one that we talked about, how to build your first agent, like this is really explaining the agentic workflow, which then is one puzzle piece of a multi-agent system, and also talking about the productivity boosters that those agents can bring. So feel free to also watch these recordings out there. I hope there are some insights as well in for here, and maybe some more clarity on pros and cons of agents and the complexity that they have. So yeah, and with that being said, I would like to open the Q&A session. And I would like to invite you to use the Q&A button. So there is this, or in German, it's the F&A button. And yeah, just type in your messages. And I just want to start maybe with the very first question. How about more engineering tasks? For example, design a control system on some requirements. Can your agents do that? From anonymous question. So control systems based on requirements. Ram, any idea on this very interesting question?
Yeah, I think it's a fair point that as Synera, we are focusing more on structural, mechanical components, because what we realized was this is a very underrepresented space. And what we also have are connectors like Python and even MATLAB. So if you have a Python script or a MATLAB script, you can attach it into the workflows. And that's something we offer today. So if you can come in with a Python script or a MATLAB script or have a specific use case, there are always more modularity in Synera to do this. Of course, we have a lot of connectors to FEA simulation, CAD design, and so on. But we want to keep the space open for these use cases to be broad. So yeah, that's an interesting question. Points also into one of the most interesting questions to ourselves. And if you have like a concrete use case, please reach out to us. I think there are always ways we can see how to bridge it.
Oh, thank you very much. I like this answer. There's a question which kind of resonates also with this thing, because if you have these multi-agent systems, they also need to be connected to tools. And there's one question from Srinivas, and he asks actually if it's possible to connect, for example, to intact simulation, like these, let's say, additional meshless, mesh-free simulation tools. Because this actually, I would assume, speeding up the whole FEA process pretty much.
Yeah, absolutely. I think one of the principles we have in Synera is let agents not hallucinate. And with that, we mean the engineering calculations need to happen in engineering tools. And that's why we separate this. So the tools will remain engineering tools, and the agents, they are used for what they are good at. So it doesn't matter now then what the tool contains. It can be OptiStruct solver, which is available in the marketplace, but it also can be the Intact solver, which is available in the marketplace. It could also be Synera solver. So the agent really is only focused on communication and using the tool, and we expert engineers can design what's in the tool. So short answer, yes, we can attach this Intact solver or actually any engineering tool as a tool for the agent to let it call and use this tool whenever needed.
Amazing. Thanks, Ram. Maybe a kind of like attached question is from Forte. We did mention Facton was used. If we can elaborate a little bit more on this topic. I guess it's definitely something which is highly required in the RFQ processes. So yeah, maybe Ram, you want to take it. What do we do with Facton?
Yeah, sure. I think, Maurice, you also have a lot of insights with Facton, but my comments first. I think we have a connector to Facton based on API connection. So that means if you're already a Facton customer and you have some Facton costing models, it's easy to build workflows and utilize them. We have customers using Facton, and that's why we have a connector that's even today downloadable from Marketplace. But Moritz, I think you have also seen some use cases and different.
Absolutely. So I guess if you're going down the road of should costing, you really need to be precise and accurate. And I guess as mostly the cost engineering teams using these software tools, like for example, Facton, they know how they price and how they cost actually the parts. So we try to connect to those software tools because especially if you use, for example, Facton for should costing calculation, you are sure that the agents come up with the right price like you would do as a human. And I guess especially if we talk about euros, nobody wants to be with the wrong tool here. So yeah, there's a partnership going on with Facton. If you are more interested in this, let's have a chat on this also in the aftermath. A very interesting question from Alejandro here. How have your experience been with different large language models for different tasks? Like, for example, routing and coordinating, or complex reasoning, or summarization. So is there any recommendations on LLM selection? And I guess I also saw it in the demo around that you showed that there's possibility to connect multiple or different types of LLMs. Maybe you can elaborate a little bit.
Yeah, sure. I think it's one of the most exact questions we need to be asking. Like, do we need powerful model for everything, or can we work with slower models? And one aspect I always think of is the costs are sometimes negligible. Of course, there are like these pro models, flagship models, which cost $50 per use, but also if we then come to distinguishing between using GPT-4o mini versus GPT-4.1 mini, the cost is really not the factor anymore. So there is, of course, a cost discrepancy, but it depends on which zone we are in. And to answer, I think what we need is to understand which kind of models are suitable for which tasks. So for example, let's say we need reporting. It's easy, it's enough to use a text-based model. We don't need a multimodal model. We need to, for example, look at images, or let's say process stress results or something like this. We of course need these multimodal models. Then we need, today in Synera, we have the capability to connect to AWS models, Azure models, OpenAI. So that means you can really optimize agent costs. And what we're also working on right now is to kind of establish this benchmark to see which model is suitable for which one. We have some first insights in the next few weeks and months with more recommendation. So I will keep this in mind, Alejandro, always your question.
Perfect. Thanks, Ram, also for like pointing this out. There's a very interesting question here about, I guess, like quality. And I guess what metrics, methodologies, and frameworks are we recommending for managing this multi-agent system? So, for example, for evaluating and establishing accuracy and trust during development, for monitoring and continuing the improvements, or for continuous improvement, and for root cause analysis, traceability, and finding error during operations. And I pretty much like this question because this is popping up in all of our discussions at the moment. Of course, you want to know what the agents do. You want to be able to have traceability, whiteboard, no black boxes ever. So what are our thoughts on this, on this kind of like traceability and white box approach?
Yeah, I think it's a brilliant question. And the honest answer is we are all more to this direction, especially what's going to work for engineering agents. But some of the ways we ensure this, that nothing remains a black box, is by giving you the. So what we do on a more front-end level is to make sure you can see what the agents communicate. So you can always see what different agents talk to and how they do this kind of the first step. Moritz, is my connection breaking? Is it all fine?
I hear some like pauses between your talks, but I'm not sure if it's only me or if it's on your side. But I get the bigger picture. Just continue.
Okay. Yeah. Okay. Yeah, that's great. So what we use is a lot of these LLM ops observability tools behind the product, and you as a user can always check what the agents are doing, what the agents are talking to, and we also use an eval-based system design to make sure we can improve the agents. So that's on a top level, highly technical, but what we make sure is the user, or you as an engineer, can really see what agent communicated what and what tool was used and what was the output from this tool. I think that is more important for transparency to engineers.
Oh, I like this. So I guess really like being able to also like start with very first agent. Was also a good recommendation to building the systems. Start with the first one, see input, output, if this is really reliable and if it matches your expectations. And if you have like clarity on the very, very first agent, then you add the second agent, because with more complexity, you then can like cut down the root causes of potential errors or bugs to the agent which you just have plugged in. I guess, yeah, it's something complexity, break it down. first principles thinking and having the possibility to look into all the details of the processes. A question from Danny actually is, we've seen lots of mechanical CAD, MCAD solutions. What about ECAD, like electrical CAD solutions?
Yeah, I think it goes similar into the direction of the control systems. So Synera, primarily we are trying to focus on structural simulation, CAD and FEA. And we have an open API platform. That means we can connect to all systems, basically every engineering tool that has an API connection. In our marketplace today, there are connectors for, let's say, wire routing. There are connectors even to additive manufacturing. And of course, this ECAD is a direction we are looking into. But again, as I mentioned, if you have a strong use case that is like an RFQ or that has this complex domain process, please reach out to us. And I think we have a lot of integration capabilities to do these things. As a quick solution would be to use scripting solutions. So we are strongly integrated with Python, with C#, with REST APIs. So integration shouldn't be a problem with Synera at all. So that's the short answer.
Open platform, I like this. Thanks, Ram. Another very technical question, but I guess it popped up several times here also in the chat, is about RAG systems. So especially retrieval augmented generation filters. And the question is actually, are these agents connected to a RAG system to get information or specifications from that are specific to a project and dynamics? So if yes, how does each agent know if it's scoped from this database?
Yeah, again, a very technical but also on-point question. Again, a database differs from company to company. I have seen some companies use just one Excel sheet as a database. Some company have a sophisticated REST API platform as a database. At the end, what we want to make sure is the agent can connect securely and not mess up this database. And that's why what we have is connectors to Excel, and then we attach them as tools, for example, to Azure. As an example, then the Azure OpenAI uses the RAG system. So what we do is we safely kind of connect to this Excel file and transport it to OpenAI, then do the RAG and get it back. And how does the agent know the scope? Again, simple, but the effective answer is through prompts. So we can assign prompts to the agent's persona, but also assign system prompts or instructions to the RAG system itself when we do the query. Again, very happy, Mahmoud, to kind of exchange more and more questions or ideas about this. But as a first answer, yes, the scope is limited in the agent's responsibility and also in the tool itself. So we can kind of engineer the tool that the whole database is not available, but it can smartly use what is exactly needed.
Amazing. So I guess also like this kind of principle boils down into, for example, defining what manufacturing machines you have in your shop floor. So it really gives you the opportunity to have like an industry or like a company informed agent acting at some point. So highly relevant for sure. Kent was actually asking about how about these agent roles. So as you explained in your video, Ram, we had these commodity analyst agents with them governing rules and tools and data, the assembly planner. So what are actually like the distinction? I guess the question goes into that direction about the governing rules and the tools and data that they access. But also, Kent, if I understood your question in the wrong way, please chat again here, or also like put it again in the question. But I would interpret it as like, what are governing rules and tools and data and how they differ between these agents we've seen in the RFQ process?
Yeah, I think one notion, it might again sound simple, but one notion we always have inside Synera is let's look at what are people's roles in our customers. So if there is a commodity analyst really in your company, we start by just mapping out their roles. What are they doing on an everyday basis? Are they talking to this engineer, that engineer? Then we write it down. Are they using this tool and that tool? We write it down. Then we see what are their typical tasks, and we can craft these roles. And those are also the inputs we see in a supervisor or agent, that there is a goal, there is a responsibility, there is a rules and boundary, and then there is a description. So again, we are trying to optimize this a lot to make this effort of digitalizing these roles and responsibilities a lot But as a first starting point, when we talk to new companies, they give us a super new agent. We ask them, who is the person actually in your company doing this task? Let's talk to them. Let's understand their day-to-day task, and let's put it into an agent and see if they get benefit out of it. So that's how we would approach it. Just try to understand from engineers, what are their roles, what tools do they use, and then we know what can we connect and what can we give to an agent. For example, there are some systems which have a lot of authentication that is not yet safe to give to an agent. So we still leave out these kind of systems to human engineers so that they are in the decision making, which we are super careful. And then the less, let's say, critical and more repetitive tasks, this goes to the agents. So that's our kind of principle in mind right now.
Thank you very much, Ram, for the explanation. I guess, Kent, I hope this was helpful. If not, let's also have a follow-up discussion later. And also looking a little bit at the watch and to the time. Maybe like one last question from the whole list of unanswered questions. We will all follow up with them in after the webinar with you individually. But one question actually from Minos Babu, I definitely would like to raise in here because it opens up like the space to our open platform on connectivity. And the question was like, can we actually integrate Synera's agents with custom-built other AI tools or agents? And I've heard some rumors that there's something going on with MCP and A2A, agent-to-agent communication. So maybe, Ram, maybe you can give us a little bit an outlook where this could be heading towards in the future.
For sure. I think when we look into this whole AI scape, what we are seeing is a lot of software providers have strong solution into one niche. Like we have at Synera more focused onto engineering, but we also see like some other companies who are more, let's say, focused onto finance or more focused onto cost. And we want to make sure that you, as our engineers at the end, don't have to worry about now connecting agents, because what we realized the last 5 years was connecting tools is a big pain. And now if we also say, hey, you have to figure out a way to connect agents, that would be not a nice way. So we are working also on a couple of these protocols that will come out in the next few weeks and months. Again, if you're interested on what we are working on, directly feel free to reach out to us. But we are making sure that we are open, we keep this open compatibility. So you as engineers don't have to worry about multiple systems again and multiple tools. We will make sure that all these agents can talk to external agents, use external tools, and so on. For sure, we keep this in mind.
Amazing. I guess with that being said, Ram, I would like to end today's webinar. I would like to thank everybody for participating, also for staying that long, the whole hour with us and asking all of these questions. It's always amazing to interact with you in these webinars. I'm already looking forward to the next webinar together with you, Ram, on AI topics. And again, if you are more interested in, there's some also like a YouTube playlist that you can scroll through. Lots of information on building agents, how you actually can do this. So feel free to watch them, ask questions, and I hope we'll see each other again in the next webinar series. Ram, greetings to India. I hope you also have a nice time and come back safely.
Yeah, thanks so much, Moritz, and thanks everyone who joined all around the world into this webinar. Looking forward for further conversations. Thank you.